session of what we'll be doing in class tomorrow, and this is covering chapter 13 material dealing with solutions and calculations involving different units of concentration. So the main thing with chapter 13 is talking about solutions. So one of the things we'll be doing is converting from different units of concentration to other units of concentration. So for example, we have molarity, molality, mass percent, and mole fraction. So these are the four common concentration units. Now molarity you learned in Gen Chem 1. Molarity is moles of solute over liters of solution, dignified with a big M. Molality is moles of solvent over kilograms, moles of solute over kilograms of solvent, and it's denoted little m. Now little m, not to be confused with mass, little m means molality, and I apologize I can't write straight. Mass percent is mass of solute over mass of solution times 100. Finally, mole fraction is moles of solute over moles of solution. These are the four common units of concentration, and in this chapter we'll learn about converting between the different units like this. Now one thing to remember is that solution equals solute plus solvent. So to get the solution, you need solute plus solvent gives us solution. So take a moment, look at this, then we're going to move on to the problem today of converting different units of concentration. Molarity, molality, mass percent, mole fraction. These are common ones. There's other ones as well, but these are the common ones. Alrighty. So now looking at this problem, we want to determine the molality, the molarity, and mole fraction for 11.92% solution of sodium hydroxide. So we want to determine what's the molality, the molarity, mole fraction for 11.92% solution of sodium hydroxide. In addition to the mass percent, it gives us the molar mass and the density of the solution. So when you're doing a problem like this, the first thing you need to do is write down these different we need to acquire different types of information. So what we want first is we're going to need the moles of solute, moles of solvent, mass of solute, mass of solvent, mass of solution, volume of solution. Oh, no use to clean. I like this good. These are so as you can see, moles of solute, moles of solvent, mass of solute, mass of solvent, mass of solution, volume of solution, and also one more, moles of solution. So by having all these different components, we can convert to the different units of concentration. So while you write that down for a second, well, before we move on. Now the first step when we're doing a problem like this is we need our assumption. And so the assumption is based on what our original concentration unit is. So here we're dealing with mass percent. So that's what we're given, so that's what we need to base the assumption on. And so for mass percent, the assumption is, let me write that better, mass percent assumption. So mass percent assumption is 100 grams of solution. So when we're given mass percent, we assume 100 grams of solution. And if we know it's 100 grams of solution, we already know our mass of solution is 100 grams. Since it's an 11.92% solution of sodium hydroxide, we know the mass of solute, 11.92. And mass of solvent, remember solution equals solvent plus solute. And so if we know the solute and solution, we can find the solvent. And this would be what? 88.08 grams. So without doing any calculations, we've determined the mass of solute, we've determined the mass of solvent, and the mass of solution. Again, the assumption is the mass percent, 100 grams of solution. So now what we need left is to find the moles of solvent, moles of solute, volume of solution, and moles of solution. So first we'll deal with moles of solvent. Now since we're dealing with an aqueous solution of sodium hydroxide, the solvent is water. Water has a molar mass, 18 grams per mole. So most of the time you're dealing with water. If it's something other than water, it will tell you in the problem. But here, since we're dealing with sodium hydroxide solution, we know that the solvent is water. So to find the moles of solvent, it's mass divided by molar mass. We'll take the mass of solvent divided by the molar mass. And we'll get 4.893 moles of solvent. And so that goes. That's the moles of solvent. And a good check is the moles of solvent are always going to be greater than the solute, because solute is the smaller component, solvent is the greater component. Now to find the moles of solute, we take the mass of solute, which is 11.92 grams, and divide it by the molar mass, which is given to us, it's 40 grams per mole. And this will give us the moles of solute. So we get 0.298 moles. So that goes here. So now what we need is the moles of solution and volume of solution. The moles of solution is easy. You can take the moles of solute plus moles of solvent gives us moles of solution. You get 5.191. Now to get the volume of solution, this is the last thing we need. To get the volume of solution, we're going to take the density which is given to us and the mass of solution to find volume of solution. Now, the one thing to note is you only need density when you need to calculate molarity. So if we didn't need to calculate molarity, there's no need to have the density. Density is only needed if we need to calculate molarity concentration. So now to find the volume of solution, remember density equals mass over volume. Therefore, volume equals mass over density. Now remember, this volume is going to be in milliliters. But the volume of solution we need to be in liters, because molarity is moles per liter. So therefore, volume equals 100 grams divided by 1.13 grams per milliliter. And so we get 88.50 milliliters, which would equal 0.08850 liters. So this is the volume of solution. So now we have all of these different components. We can calculate the different units of concentration. So I'll give you a few minutes to look over this, a few seconds, and I'll erase it. And we'll move on to calculating the different units of concentration. Excuse me. All right. Here I'm going to erase this. So the units of concentration we want big M, which is molarity, little m, which is molality, and mole fraction of solute, which is X. So these are the three units of concentration we want. So again, we want molarity, which is moles per liter. We want molality, which is moles per kilogram of solvent, and we want the mole fraction of sodium hydroxide. Now for molarity, molarity equals moles of solute over liters of solution. So moles of solute, 0.298. Liters of solution, 0.08850. And the molarity is 3.37 moles. I'm not a big stickler for significant figures. As long as you put it to the hundredth place, that's good enough for me. So this is the molarity of the solution. Now to calculate molality, it's moles of solute over kilograms of solvent. So the moles of solute, 4.893. Oh, excuse me, no. The moles of solute is 0.298. Kilograms of solvent. So this here we need kilograms. This is in grams. So we've got to convert this to kilograms by dividing by 1,000. Here. Then we get about 3.38 molar. Now, it's not too far off because, the density is, where's the density? Density is not too far from 1. The closer you are to 1, the closer these two values are. So we would have went back and wrote 4 significant figures. This would be 3.383 molar and 0.298 divided by 0.08850. 3.367. Let's change this so we show you that they're different. So I went and I wrote 4 significant figures instead of 3. Now we know the molarity, we know the molality. They're they're not too far apart because, again, the density of the solution is not that far from 1. Now, mole fraction, we take the moles of solute, which is 0.298, and divide it by the moles of solution, 5.191. Now, mole fraction means it's a fraction, so it should always be less than 1. If your mole fraction is greater than 1, you've done something wrong. 0.298 divided by 5.191, and we'll write it before significant figures like this. And so this is the mole fraction of sodium hydroxide. And so that concludes today's lecture. Give me a second.